Welcome back to the certainty of uncertainty in chapter 2. We are diving into the language of probability and notation. Let's get started. Today we cover introduction to set notation, overview of sets, basic notation, set builder notation, set relationship, cardinality, marginal probability, union probabilities, intersection probabilities, complement probabilities, and conditional probabilities. Let's jump right in. In that wrap up chapter 2 of the certainty of uncertainty, we laid the groundwork for understanding probability through set notation. Stay tuned for more insight. So let's get started. First thing first, what exactly is a notation? Well, thinking of it as a secret code that helps us describe and understand collection of objects or elements called sets. These sets are fundamental in mathematics, aiding us in organizing data, defining relationship between elements and solving problems across various fields. Now, let's dive into the basics. What exactly are sets? Set are collection of distinct objects or elements grouped together based on a common characteristic or property. They like the building blocks of math, providing us with a structured framework for organizing data and solving problems. For instance, consider the set of natural number, the set of even number, or the set of prime number. Each of these sets demonstrates the versatility and applicability of set across different domains. Next, let's talk about some basic notation used in set theory. Hosts are typically represented using curly braces. For example, 1 to 3 denotes a set containing the element 1, 2, and 3. We use the symbol each an element of to indicate that an element belongs to a set. And don't forget about the empty set, which contains no element, and the universal set, which encompasses all elements under consideration. Finally, let's discuss some set relationship. A set A set B is a subset of another set A if every element of B is also an element of A. If B is a proper subset of A, it means that B is a subset of A. But there exists at least one element in a that is not in B. And let's not forget about set operation like in intersection and union, which help us combine or compare set. Start with marginal probabilities. Imagine we have a joint probability distribution for rolling two dice. We want to find the marginal probability distribution for each die individually. This would tell us the likelihood of each possible outcome on each die, regardless of the outcome on the other die. For example, for die X, we be interested in the probability of rolling A1, A2 and A3 and so on. Similarly for die Y, we want to know the probability of rolling each number from 1 to 6. This allows us to understand the individual probability for each die. Next, let's talk about union probabilities. Intersection probability help us understand the likelihood of two events occurring simultaneously. Consider the probability of getting head on both coins. When flipping two coins, this is an example of union probability. We are interested in the likelihood of both events happening together, which is crucial for understanding the joint probabilities of related events. Lastly, let's discuss complement probability. Complement probability represents the likelihood of an event not occurring. For instance, if we have a probability distribution for rolling a six-sided die, we might want to find the probability of not rolling a 6. This helps us understand the entire probability space by considering events that do not happen. And there you have it, a brief overview of marginal, union, and complement probability. Understanding this concept is essential for tackling more complex problems in probability theory. Thanks.